Let's talk vertical asymptotes. Now, vertical asymptotes are vertical lines that a graph will approach but never touch. So oftentimes, if we have a graph on a coordinate plane and you see a vertical asymptote, it is usually marked by a dotted line. And so if we were graphing something, it would approach this line but never touch. So maybe the graph looks something like this. But that's the idea, is that it will approach it, will never touch it. So x, in this example, there would never be an x equals 2 because 2 is where our vertical asymptote is. Now let's consider the function f of x equals 1 over x. We're going to start with what is the domain of the function? Well, when we have a variable in the denominator, we know a denominator cannot equal 0. Therefore, if we think, well, if x is 0, the entire thing is undefined. Because if x is 0, we would have 1 over 0. We can't have that. So the domain of the function is negative infinity to 0 and 0 to infinity. Or everything except 0, right? Now, when we think about the vertical asymptote of this graph, if we were graphing this, we would say, okay, x can never be 0, right? We know that x can't be 0. So our asymptote would be at x equals 0. So the idea of the asymptote is really, where is the graph undefined? We can't have a value of x equals 0, so that would be where our asymptote lies. When we look at this here function, f of x equals 2 over x minus 2 and x plus 5, well, again, if we're thinking about vertical asymptotes, we look at our denominator. Where does the denominator equal 0? Well, this is already in factored form, so x equals 2 and x equals negative 5. Now, when you get into vertical asymptotes, sometimes you also need to think about holes or discontinuities in the graph. But the issue there comes in when you have more variables and things in the numerator. If you only have a constant in the numerator, you're just going to have vertical asymptotes. So in this case, we know that x can never be 2 or negative 5, because if it's either of those, we're going to have a 0 in the denominator, which we can't have. So we would have vertical asymptotes at x equals 2 and a vertical asymptote at x equals negative 5. And that is how we find vertical asymptotes.